There is a lot of aspects for rail safety, and what we're doing here is kind of the raising awareness and education, trying to inform students at an early age about the different aspects of rail safety. Like, what are the technologies that we can do to keep the railway safe? You know, why is rail transportation important to us? You know, the economic aspect of it, and why is it important for us to keep the operations running safely, reducing derailments, reducing accidents. This is just a kind of an overall picture telling kids that, hey, there is this thing of railway safety and keeping the rail transportation operating in a safe, economic and efficient manner. Here, the camps are split into like elementary, which is grades 3rd to 5th, and then middle school grades 6 to 8, and then high school grades 9 to 12. Every grade level has grade appropriate curriculum that were developed that meet the TEKS, with the Texas Essential Knowledge. We try to line up the modules, the teaching modules, with stuff that the students learn about, for example, like friction. You know, what are things that can restrict your movement? The laws, the basic laws of Newton. Okay, and in the elementary, we try to do that with simple examples. For example, you know, we inflate a balloon and we put it on a string, and then we let it, you know, basically move, and the students are timing the distance, right, and the time, and then this way they can calculate the speed of that balloon. They also learn that, hey, the more you inflate the balloon, the faster it's going to go. Why? Because of the pressure buildup. So even though they don't understand all of these concepts, they're starting to just look at the different aspects, understanding how speed is calculated.
Well, elementary and now it's basically the same thing, just here it's a little bit more complicated.
Code.org, and it's really helpful with the drag and drop process of the coding for the little robots. But there's still stuff in the robots that you have to change, and you can't never find out.
Elementary was a lot more simpler. We weren't really using any more devices. It was more scratch, but now it's more advanced. In middle school, now we're coding.
We're putting how much speed it needs to use and move that way.
We get to input all the details.
In the middle school, we try to challenge them, and we try to bring in programming, but they do programming, so they learn one aspect is logic and programming, but then giving them challenges that are applicable to engineering applications. For example, like, can you program this robot to navigate to the rail tracks and remove an axle and bring it back? So even though they're learning to program, we give it a rail safety flavor or transportation flavor so that they can relate. Why are they doing this? They also learn higher aspect of speed, like how does speed affect load? So, you know, why are trains more likely to travel slower when they're loaded versus unloaded? And so they're starting to put things together at that level.
We're trying to see how our bots can carry a certain amount of washers, and that we were doing basically the same thing except with the trains. And we were connecting more weights to see how much it could pull and how fast it would go, faster or slow. We learned about different types of transportation for cargo.
And that railway safety is one of the cheapest to use.
In elementary it was fun, so I thought it was going to be like fun also, and it is.
And I learned a lot in elementary, so it made me want to come back and learn more.
high school, we challenge them even more. So the programming becomes less step-by-step and blocks, and more kind of using Python, C++, and higher levels of programming that students in university use. And they're still challenged to do aspects like understanding sensors, sensor technology. How does these sensors affect infrastructure? You know, line followers, like touch sensors, color sensors, even ultrasonic sensors. And so it's kind of like increasing the level of difficulty and getting them ready for when they come to the university.
They're learning, a lot of it is this teamwork, working together and solving problems and realizing, like with engineering, that it's a process and that you have trial and error and you have to do things again. They learn science and engineering principles like collecting and analyzing data and how to make sense out of it, and how to connect the data to scientific principles, say like Newton's second law and force equals mass times acceleration.
We show them that, look, engineering is very broad, and you can be in transportation without having a specific field. There is no just transportation engineering. Transportation engineering could be in any field. It could be in computer science by analyzing the big data that comes in. It could be in electrical by creating the wireless systems and the sensors. It could be in civil in learning about policy, planning, infrastructure. So these camps just tell you that, hey, if you want to be an engineer, you have to have certain traits, like what's the engineering design process? Well, how do you start thinking like an engineer? How do you work with teams? How do you collaborate? So that's the goal of these things, is to get you into that mindset, but it's not to just recruit for one discipline or the other.
My favorite part of engineering is breaking things down and making things. With Bob the God.
Bob the God.
He's the best. He's gotten 3 upgrades. He has a new model, which is faster and cooler. Yeah, that's my favorite thing about making things and understanding all of it. What about you?
Igual mi parte favorita pues fue construir el robot, me gustó mucho porque es algo que jamás había hecho. Bueno.
Well, this has really helped you with my communication skills. Like, it has helped with like everything and my learning. So yeah, I encourage them to come here.
It's really fun to learn how to work with others and to build the robots.
I want to be an engineer.
Me too. Because you learn a lot in the class.
They should try and pay attention, because you can, if you really want to be an engineer, you can learn a lot from this class.
I would walk around and I would hear the conversations. They were very focused on the engineering design and why something wasn't working or it was working, and also, you would hear them using the scientific language, around why something wasn't working. And I think, but in general, they were just, I saw excitement, like, in pretty much every way possible. They were also just having a lot of fun, making new friends, right? And like I said, the collaborating.
There's a lot of things that these camps do, and you can see some personalities completely transformed. There are some people that are confident to begin with. They come in, they know they want engineering, and they do well, they're excited about it. But the bigger impact in that those personalities that come in with some doubt, they don't know, should I do this? Can I do this? And by the end of the camp, you see them doing so well and thriving and wanting to come back and learn more. So those are some of the things that these camps do that it's hard to do in the classroom. And it's hard to do unless you surround these kids by other people like them who might be shy, and through these they gain the confidence to be a little bit more outgoing.